So we're going to start with example number 15, problem 53. It talks about an electric motor on a model train accelerating the train from rest to 0.62 meters per second in 21 milliseconds. We are given the mass of the train, and we want to know the average power delivered to the train during its acceleration. Because our train is accelerating, we must use the equation power equals work over time, which means we need to calculate the work that is done. Now, there are multiple ways to do this, but clearly the easiest way is to use the equation net work equals the change in kinetic energy. And we know that change in anything is final minus initial. So we have the final kinetic energy minus the initial kinetic energy. Well, it tells you that it starts from rest, which means the initial kinetic energy is 0. So we simply need to find the final kinetic energy, or 1/2 mv final squared. Now it gives us mass in grams, and of course we need mass in kilograms. So converting my number, I have 875 grams, which is 0.875 kilograms. And my final velocity that I'm given is 0.62 meters per second. Don't forget to square that number. And then I plug that into my calculator, and I find out that the net work, or the change in kinetic energy, is 0.168 joules. So I'll take that number, 0.168 joules, and I'll plug it in up here as my work. And I'll divide that by the amount of time, 21 milliseconds, or 0.021 seconds. And I find that the power delivered is 8.01 watts. And the second example problem that we didn't get to the other day deals with an automobile driving at a constant speed down a highway. It tells us that the power developed by the engine is 175 horsepower. We wanted to estimate the total frictional force acting on the car when it's moving at a constant speed of 29 meters per second. And then they give us that nice conversion factor, 1 horsepower equals 746 watts. So the very first thing we're going to do is convert horsepower to watts. So 175 horsepower times 746 watts divided by 1 horsepower. That gets rid of the horsepower units, and we find out that it's a rather large number of watts. 130,550 watts. And because we are looking for force, and it's asking that it's moving at a constant speed, I'm going to say that power is force times speed, which means force is the power divided by the speed, or 130,550 watts, divided by 29 meters per second. This gives us a value of 4,501.7 newtons. And that is our final answer, because since it is moving at a constant speed, the force of friction is approximately equal to the force of the engine. And our engine is what is developing that 175 horsepower of power. And so that would be the force of the engine, which is approximately equal to the frictional force. Now, of course, they're in opposite directions, but that's the magnitude.